Okay, let's talk more about these expansions. In the last video we looked at some of the patterns that you can look for. They become important when we look at these more complicated expansions. Sometimes these pairs of brackets can actually be added or subtracted from each other. It's important that when you've got these complicated looking expansions, that you don't freak out first step. Just take your time. You want to work slowly. You want to look for those expansion patterns. You always want to collect the like terms as you're going through them. And you work on each of these pairs of factors that are between the big sort of plus and minuses or whatever. Do them separately. You work on each bit by itself. Well, what do I mean by that? Well, let's have a look. Here I've got one. I've got a big, complicated looking expansion, but let's just think about what it is that we're going to do. Okay, I've got these two factors over here. Here's one factor, another factor. I've got this plus, and then I have these other two factors, this factor over here kind of tacked onto the end. I'm going to expand out each set of brackets separately. I'm going to make sure I don't mix them up until I can, right? Because this plus right here means that it really divides this expression into two parts. There's this part over here, and then there's this part over here. If this was a multiply sign, well, that would be a different story, but it's not. Okay, so over here I'm going to use there's no pattern I can use. They are not the squared. They're not the difference of squares. They're just a binomial. We're just going to have to expand them out using the FOIL method. So we do our firsts and we get x squared, and then we'll have plus 4x plus 3x and then plus 12. And I can also multiply out this second section and I will get just this. I will have the 4 here multiplies by each thing on the inside of the brackets, 4x, and then I'll have minus 8. And I have this great big long line of all these different terms that I'm now looking to find the common things, like the things that are like terms. Okay, so I can have a look and I can go, well, you know what, here's an x squared. I don't have any other x squareds, so my answer will only have a single x squared. Alright, so let's have a look for some x values. Well, I've got an x value here and an x value here and an x value here. So 3 plus 4 plus 4 will equal 11. And the only thing I have left are constant terms. I've got plus 12 minus 8, which eventually will lead me to my answer, which is just x squared plus 11x plus 4. Okay, there you go. Let's have a look at another one of these. This time we want to, I've made it so that there's some patterns involved, because we want to be able to do these where there's those patterns, because it makes things a whole lot easier. Okay, so here is our complicated looking expansion. What patterns do we see? Okay, well, over this sort of side of this minus, I've got the difference of squares, x plus minus 2, x plus 2. Alright, do you remember what that will look like? Well, really quickly, a plus b, a minus b will be a squared minus b squared. Okay, so we can use our understanding of that over there. Over this side I have the 2 squared. I got x plus 3 times itself, x plus 3. So if I've got a plus b multiplied by a plus b, I'm going to have a squared plus 2ab plus b squared. So I can use those little formulas, the patterns that we've already learned, and I can apply them here. So if I apply my first pattern, this one, over here on these difference of squares, I know it will be x squared minus 2 squared. That's what it'll be. And this one over here, it will be, well, x squared plus 2 lots of 3x plus 9. Eventually it will be. Okay, so let's check them bit by bit. Well, here's the first one done. I just did this left hand side, this left bit, x squared minus 2 squared, that's what that will be, minus, and you'll notice I've left this bit in brackets. That's important and I'll explain why. Okay, let's have a look at the next step. Now that I've already done this section, I can concentrate on what's in the brackets here, and it will be this x squared plus 2 lots of 3x plus b squared, but this is it, 9 plus 9. Okay, so now I'm at that point where I want to take away those brackets, but it's really, and this is really important, here I have a minus sign. So in reality, really, I have a sneaky 1 just here. 1 outside of these brackets. It's like -1 multiplied by everything in here. So the upshot of that is that when I get rid of those brackets, you will see that every sign that was attached to these terms before has now changed. This was positive x squared. Well, now it's negative x squared. This was positive 6x, but now it's negative 6x. This was positive 9, it's now negative 9. So when you get rid of the brackets, if there's a minus sign in front of the brackets, there's really a sneaky -1, even though it's not there. Don't miss that, otherwise you'll make errors. Okay. Alright, so now I look for my like terms. Once again, like terms are very important. I have got an x squared minus an x squared. Okay, I won't have any x squareds in my answer. I only have one of the x values. It'll just be negative 6x, and then I just have constants, -4, -9. And my final answer will be negative 6x minus 13. Okay. So there it is. That's why it's really important to look for these patterns, because they can make things easier for us and we don't have to do as much work. Okay, one last example I think, and then we'll move on from, we'll stop this video. Okay, so here I have my next example. And now what's different about this one is I've just got a single number out the front of a pair of brackets. How do we deal with that? Well, it's important to remember that multiplication is commutative. We can do things that are terms are being multiplied together in any order, and it doesn't matter. So you could multiply out this 2 and this first bracket first, and then multiply by the second bracket, or you could multiply out these 2 brackets and then multiply by 2. Doesn't actually matter. And over here, look, we've actually got another one of those sneaky little rules. Do you remember this rule? This is one of the perfect squares rules. So if I've got a minus b, it will be equal to a squared minus 2ab plus b squared. All right, so we'll be able to apply that rule, that pattern in this one. All right, so I'm going to multiply out using the FOIL method and also using my rule, and I will get this. You should be able to tell why I got this. I'm not going to go through it every single time. You should be getting practiced at this by now. X squared right there, negative 4x from our outside values, plus 3x from our inside values, negative 12 from our last values. So now I have all of this still in a bracket with a 2 out the front over here, and over this side I used my rule. I know it was it'll be x squared minus 2 lots of 2x, there it is there, and then it'll be plus this last value squared. Okay, so when I multiply out the brackets, I will have 2x, 2 times x squared, 2x squared, minus 4 plus 3. Well, I had to do this first, so minus 4 plus 3x, that'll just leave me with negative x, and then negative x times 2 will be negative 2x. Negative 12 times 2 is negative 24, plus, and because there's a plus here, I can just get rid of these brackets and I don't have to worry about changing any of the signs on these ones. So it'll just be x squared minus, well, 2 times 2 is 4, 4x, plus 4. There it is there. I look for my like terms. Okay, so what like terms do I have? Well, I have a 2x squared and I'm adding an x squared. So there's 3x squared there. I've got a negative 2x and a negative 4x. It'll be negative 6x. And then I have my constants. Negative 24 plus 4, I'll have negative 20. And so when it all comes together, that's exactly what we have. And I've just realized that you probably can't see what's under that little bracket under my face there. So there we go. That's better. That's a bit more centered so you can see and read it a bit better. So these more complicated ones, while there's more to do in them, what you're actually doing is no different than what we've done before. They look intimidating, but they're really not intimidating when you break down these complicated things into their simple parts. Okay, it's just like spelling a great big long and hard word by breaking it into little sections. You just break this into little sections and you work on each little bit until you're at a point where you can gather your like terms and you write your final equation. Well, it's not equation. Someone laughing in the background. Sorry. You write down your final statement. Your final. I can't think of the word. That bit there. This bit. Expression. That's it. I knew it would come to me if I stopped trying to think about it. So you write your final expression after you've gathered your like terms, and you'll be fine. Just don't be too intimidated as you go. That's my hint for you.